409. Project Quality Management. Which of the following graphs expresses the quality of the products in chronological order and is used for determining whether the manufacturing process is in a stable state within the limits of management? Option A, control chart, B, scatter graph, C, cause and effect diagram, or D, Pareto chart. For the purposes of quality control and quality improvement, there exists a technique termed the 7 basic tools of quality. If one is to divide it further, there are in fact 8 categories. This is because some group graph and control chart into one category, and some of them treat them as separate groups, and do not include stratification. So the number is sometimes disputed, but it's about 7 to 8 categories of quality control and quality improvement. The categories are stratification, Pareto chart, cause and effect diagram, histogram, scatter diagram, check sheet, control chart, and graph. We'll be looking at each one of these in order to see what they actually mean. Let us begin with stratification. Stratification involves the sorting of data into groups in order to put out the main elements in each sample population. So this is all about sorting data. Now, since it's about sorting data, it doesn't involve any graphs or diagrams. For example, one could sort the data into stratums based on time, geography, workers, or products, etc. Through this sorting process, dividing the data into groups, the characteristics that exist between the data that previously seemed obscured can be identified. The second category we had was the Pareto chart. In this type of chart, it shows the individual values in order of their sizes by bars, along with the accumulated total being represented by the line. So this kind of chart is a mixture of a bar graph and a line graph, and we can see this in the example on the right. The bars are representing the individual values in order of their sizes, and it also shows the accumulated total. This is the sum of all the values of the bars, going up to 100% here on the right, represented by the line. Now the chart is used for ABC analysis, which is a method to identify the specific items that would have a significant impact on issues such as the control of goods in stock. So the chart is used for another type of analysis known as an ABC analysis, and it is important on issues such as the control of goods in stock. The third category we had was the cause and effect diagram. Now these diagrams present in a graph form the relationship between the characteristics, so these are the product's performance and the functions, and its effects, along with the speculated primary factors. Now by primary factors we mean the reasons affecting the characteristics. So these are the primary factors, are the reasons affecting the characteristics. Marking the speculated primary and important factors on the completed cause and effect diagram, one could then proceed to setting a theme to problem solving. So this is about aiding problem solving. From the shape, some refer to it as a fishbone diagram because it looks like the bones of a fish. You have some stemming from the middle and some arrows stemming from these primary stems. By identifying the relationship between the outcome and the cause that led to the problems, one has effectively identified what needs to be improved on. Another category we had was the histogram. The spread of the data is represented by the size and the shape of the bars on the graph. Now note that in a histogram, the data is represented by the size and the shape, unlike a simple bar chart where the data is represented simply by the size. In a histogram, the shape is also representative of the data. The range of the data is divided into appropriate sections, and within each section, the data that fall within it is charted. The vertical axis deals with the frequency, and the horizontal axis deals with the division of data. And you can see the horizontal axis here and the vertical axis here. This is also sometimes referred to as a distribution map. From the center of the data distribution and the degree of dispersion, one can grasp the nature of the work and products. So this is an example where the data is shown pictorially, and it's something that you can see in a flash. The shape actually represents something. So histograms are extremely important. Another important diagram is a scatter diagram. Now these diagrams are graphs that deals with the investigation of the relationship between two essential factors. That is, when one factor value changes, how the other factor changes in relation to that. Now this is an important point. Scatter diagrams are extremely important in seeing the relationship between two factors. We often talk about how one thing can affect something else. One would take the x-axis and the other axis. The measured values are expressed as dots. One could grasp whether there is a relationship between the items. So of course, again, we're talking about a relationship between the two variables. And if so, what type of relationship is there? In the event that when x increases, y increases, it is said to have a positive correlation. This is a familiar concept to most of us from mathematics. If when x increases, y decreases, so if x goes up by 10, y goes down by 5, for example, then it is said to have a negative correlation. If in the event that it seems that there's no relationship between the two, or that does not correspond to any of the aforementioned, i.e. there are no relationships between the two items, then it is said to have no correlation. So when we're talking about scatter diagrams, we generally say that there are three cases you can have. You can have the positive correlation case, where when one goes up, the other goes up, and we can see that in this case. This is where we see positive correlation here. And if one goes down when the other one goes up, for example, when x is increased, so x is increasing here, and we see y decreasing as we increase x, then of course this is a negative correlation. And we can see that there are different strengths of correlations. In these two, the data are, for the most part, quite concentrated around the central line, which would be around here, a line of best fit. In this case also, most of the points are quite close to the line of best fit, as you can see. In this case, we can see there is clearly some kind of negative correlation. There is an overall sense that as x is increased, y is decreasing. However, if we draw a line of best fit, we can see that the data are spread apart a lot further away from the line. And then that allows us to say that this is a low negative correlation, whereas in the first example we have a high negative correlation. Sometimes it is also referred to as a strong correlation or a weak correlation. And in the last example we see that there is absolutely no correlation. It seems that the two variables are unrelated, so that we say that there is no correlation. The sixth category we had was the check sheet. The check sheet is a pre-printed check questionnaire used during the investigation inspection stage. It contains the necessary items and the contents that need inspecting. Checking the result of the investigation against the check sheet, data are collected and the inspection content is gathered. Utilizing the check sheet upon carrying out a simple exercise for the purpose of checking, it also helps collect necessary data and prevent any serious mistake from arising. So we're talking about collecting some data which allows us to prevent serious mistakes from arising. This is extremely important in quality improvement. Here we have an example of a check sheet where we are listing all the possible things that are going wrong. Wrong number, for example, is one reason, info request, boss, and there could be other things. This is a simple example. And we are checking it against the frequency of these interruptions, on the telephone interruptions. And we can make a total to see what the sum of the numbers are. A control chart enables one to see whether a process is stable, as well as facilitating one in managing the different distribution, whether it be the chance scatter distribution, where even after investigation there seems to be no link, and the scatter distribution that occurs for some abnormal reasons. So now we're talking about the stability of processes. If we now first take a look at this chart, we see that the graph consists of one center line, and we abbreviate that to CL. You can see the green center line here, and two other lines on top and bottom of this center line, representing a reasonable control limit line. We have the UCL, which is an abbreviation. So let me just write this. So is the upper control limit, and we have the LCL, which is, as you might guess, the lower control limit. That's that. And you can see them on the chart. You have the upper control limit, which is bounding the center line and the graph inside it, and you have the lower control limit. The characteristic value representing the state of the process would then be plotted. In the event that all the points are within these two control limit lines, and there seems to be no tendency in the way how the dots are aligned, one could consider the process as being in a stable state. So the conditions to say that it's in a stable state, the process is in a stable state, is to show that you have all the points inside are arranged between the two control limit lines, the UCL, the upper control limit, and the LCL, the lower limit. If, as a whole, there seems to be a bias, either control concentrated upon or below the center line, then one should consider the production process as problematic. And so problematic, there are two outcomes of this analysis. It can either be in a stable state or considered as a problematic process. And so this is determined by looking at the chart. Graphs. Now graphs can be employed as a way to present data using shapes. In analyzing the data one has, it's important to compare the data and spot the changes and the trends in the data. So we can use shapes in graphs to quickly show what kind of changes and trends we have in the data, and it's a great way to visualize what's going on. By employing the correct graph for a particular set of data, it makes the process of analysis much easier, because it's so much easier to see. The key word, in fact, here is that we have to use the correct graph for the particular set of data. Some kinds of data are more suited for using bar charts, and some are not. Depending on the data and what one wants to find out, the graph that is best suited for a given set of data differs. The following lists the different types of graphs that we have. Firstly, we have a very simple line graph. One can see shifts in the items and changes in time. Typically, you'd have time on the x-axis, on the horizontal axis, and you'd have the variable on the vertical axis. And so we have here on the vertical axis number of people. So the graph is showing the number of people inside a store. In the morning at 10 AM we can see it's 2 people in the store, not very many. And by lunchtime it rises to 22, which is 11 times what we had in the beginning, in the morning. And it goes back down when it gets to nighttime, and you only have 3 people in the store. Now, just by knowing that we have time in the horizontal axis and number of people in the vertical axis, if you just straight away look at this graph, you can tell that the number of people peaks somewhere in the middle of the day, and this is a great way to visualize your data. You also have bar charts. Now, bar charts can compare the size of a value at a particular point in time. So in this case, we have time in the x-axis, except this time it is much more heavily discretized. We have each year, so it's 2005, 2006, 2007, and so on. So the sales are shown for each year, and of course we have the performance summary, whatever units they may be in, on the y-axis. And so this is a suitable kind of data to be using a bar chart. We also have the pie chart. As you can see from this very colourful example, pie charts show the percentage breakdown of a particular given point of time. Now you can see that there is no variation with time being represented in a pie chart. It would be extremely difficult to do so. However, it's very useful in showing, at a glance, how a total sum of a value is broken up into parts, into sections. And it's extremely easy to show percentages overlain on these diagrams. So as for example, you can see that sample 1 is the biggest group of this sum, whatever the values are, and sample 2 becomes next, and so on. And so this is an extremely valuable way of showing data. Next is the bar graph. Bar graphs show the changes in time and percentage breakdowns of each item. For example, in this particular set of data, we have comparisons between 2 different years. We have 2012 and 2013. And we have 5 different groups. We have age ranges in this case. And you can see how each section has changed over time. When we're talking about the pie chart and said that the pie chart doesn't really show a breakdown of time, how things change with time, the bar graph is kind of like a pie chart which tries to show the changes in time. This is showing the proportions of each section, but it's also showing at each stage how it's changing with time. So it's almost like a bar graph is a bar version of a pie chart because it's showing percentage breakdowns in different points of time. Finally, we have the radar chart, quite commonly known as the spider chart or the star chart. Now these charts show the balance between the items, the variables, and characteristics. In this case we have a 5-point star diagram. We have characteristics such as speed, reliability, comfort, safety, efficiency, and we have a scale for each one of these characteristics. Now this data looks like it is about some kind of transport method, some vehicle possibly, an ultra speed model and a super economy method. And you can see how each one changes their characteristics. For example, the ultra speed, of course you'd expect from the name that the speed would be a lot higher than the super economy, but it might not have as much reliability or efficiency. Now the great thing about this kind of diagram is that you can see the areas in which a particular project or a process is doing very well and areas where it's not doing so very well. And so it's very easy to see where things are leaned towards particular characteristics. For example, as the name suggests, the super economy model looks like it's leaned towards the efficiency and reliability and safety, not so much speed and not so much comfort. From the diagram you can see the shape of the diagram, it's quite pointy towards speed. You can see that the ultra speed model is extremely good at having a high speed and high comfort, but not so good at being efficient or reliable. Both models seem to be the same in safety, and so this is a great way to be able to analyze 2 different sets of models. If you just had tables of numbers, for example, on these it would be extremely difficult to compare them at a glance, but just by looking at a graph like this, within a minute, we've now extracted the key aspects of the two models. So the radar chart is an extremely valuable and powerful tool to be used in project management. Now to come back to the question asks, which of the following graphs expresses the quality of the products in chronological order and is used for determining whether the manufacturing process is in a stable state within the limits of management? And so the key word here is the stable state. And as we discussed earlier, when we were talking about the control limits, we talked about the upper control limit and the lower control limit, and you had the center line, which was in between the two. In the graph, it was in the form of, let's see, we have the time here, and we had the center line in the middle, and we had the control limits, upper and lower, and so this is the control chart, just to remind you. So this is the control chart. And we said that if the graph lay somewhere in between the two limits, then we say that it was a stable state. And so the graph allowing us to say that the process was in a stable state was the control chart. Control chart is option A, so this is the correct answer.